Alrighty. This is chapter 8, and chapter 8 is graphing quadratic functions. And so we're going to take the first three sections, actually, 8.1 to 8.3, which is graphing quadratics in standard form. And that's what this video is going to be focused on. There are two other parts to chapter 8. The next is graphing quadratics in vertex form. And then the last is graphing quadratics in intercept form. And so there's three different forms we're going to talk about. But this video is primarily focused on just what they look like in standard form, okay? And we're going to talk a lot about some different things, but the standard form means as much as it always has. So that means that the highest exponent comes first, and then the next biggest exponent comes next, and that's standard form. And so when we get into some of the other forms, we'll look a little bit more closely at how they're different. But anyway, the first thing we're going to do is graph the parent function. And the parent function, by the way, is just the simplest function that you have. And the simplest quadratic we can have is just x to the power of 2. Okay? And so we are going to fill in our table. I'm going to start at -3. And we're going to fill in the y value. Now here in a second, we're going to use the graphing calculator to do this, but I'm going to do this first one by hand just to kind of get you into the pattern of everything. So if we have -3 as the x value, then the y value is just -3 to the power of 2, which is +9. And -2 to the power of 2 is +4. -1 to the power of 2 is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And 4 squared is 16. Okay? So you're kind of seeing, okay, so if we have negative values, we start big, but then we kind of get smaller, and then we turn around and start to get bigger again, which is kind of an interesting concept here, okay? So let's graph this and see what it looks like. So we've got -3, +9, so 5, 6, 7, 8, 9. -2, 4. -1, +1. 0, 0. 1, 1. 2, 4. 3, 9. And then we're going to connect the dots. And most of you have probably seen these before and just not known what they were. Or if you haven't seen them before, it does look a little bit different. The only things that we've graphed so far are lines and piecewise functions and absolute value functions. So this kind of is like an absolute value where it's going to go down and go back up, except it's curved now. Okay? And so this has a fancy name. This is called a parabola. Not a parabola. It looks like parabola. It is not. It's called a parabola. Okay? It is a quadratic function, but we call the shape a parabola. Okay? So it's a parabola. Which direction does the graph open? And so for parabolas, we can have a couple different options. We can open up, as this one does, as it opens up. So we say it opens up. We'll see what one that looks like that opens down here in a second. The degree of the function. So if you remember, the degree is just the highest power. So if we go up here, the only power we have is 2. So that's the degree. Okay? This type of function is called a quadratic function. Okay, so most of this is just a review of the vocabulary, but this is a quadratic function. Okay? And then these last 4 things are kind of just characteristics, if you will. Okay, and so this next one is called the axis of symmetry. So if we go back up to our graph here, we notice that this graph has some symmetry. In other words, if we were to fold this graph in half, right down the middle here, okay, I'm going to make it as a yellow dotted line, that is the axis of symmetry. Okay, and this axis of symmetry is going to be the equation of a line, and we're going to have to remember Hoy Vux. Okay, because if you can see this line here, this is a vertical line. Okay, and so vertical lines have an undefined slope, which matches our yellow line up there. So that means we're going to have x equals And then we just have to decide, okay, where does that graph or where does that line cross the x-axis? And that's at 0, okay? I'm going to give you a little bit of a hint here. All of your axes of symmetry are going to be of the form x equals and then a number, right? You're never going to have an axis of symmetry that is y equals. That's a little bit hard to explain why, so we'll talk about it a little bit in class. But know that axes of symmetry are always going to be x equals, okay? All right, the minimum or maximum. This is also called the vertex, and we're going to talk more about that in the coming sections. But so we're just looking for the minimum or the maximum value. That's either going to be the highest point or the lowest point on the graph. And if you notice, this problem is going to go up forever and ever in both directions.
Brian Howard,
the smallest value is right down here at 0, 0. So we do have a minimum because it's the smallest. And the minimum is the point 0, 0. So the minimum or maximum is just the highest or lowest point that you have, okay? The domain, okay, if you remember, the domain are all of the x values that we could have. Okay, we're gonna come back to this because I know that some of you, domain and range was a little bit difficult. Okay, so the domain of the function are all of the x values that we can possibly put into a graph. So if you look here, think of it as riding a roller coaster. If you were riding this roller coaster, would there ever be a time in which you would fall off? So if you're riding, you turn around, and you keep going on forever and ever, but you would never fall off. So that means that all x values work, so you have all real numbers here, okay? And if you remember the range or the y values, so you come up here and you say, okay, what y values work? Or in other words, what's probably easier to figure out is what y values don't work, okay? And if you notice down here on the graph, nothing's happening down there. And things don't start to happen until you get here at the point 0. So that means that our range, our y values have to be bigger than or equal to 0, okay? So no matter what the x values are, the y values are always going to be bigger than or equal to 0. That's the range. You could write this in interval notation if you wanted to. So if you remember, all real numbers is negative infinity, infinity. And y is bigger than 0 is bracket 0, comma, infinity. But if you just want to write all real numbers and y is greater than or equal to 0, I would give you full points there. Okay, let's do a couple more. Okay, this is where we're actually going to use the graphing calculator to do a lot of the work for us. So if I've got my graphing calculator here, okay, I'm going to go to y equals, and I'm going to plug in negative 2x to the power of 2. And then I'm going to go to my graph just so I can see the picture to make sure. I'm also going to get some of this brightness down for you. I think I am. Hold on. It's just very, very bright. There we go. Okay, that's a little bit better. Okay, so we go to our graph. That's what our parabola looks like. And if you notice, this time it's going the other direction. So let's fill in our table here, and I'm only going to fill in the numbers that look like they're going to fit on my graph. Okay, and so here, you know, it'll start at negative 3 just so we have a base. It's negative 3, 18. And then negative 2, negative 8, negative 1, negative 2, 0, 0, 1, negative 2, 2, negative 8, 3, negative 18, and 4, I know we can't graph it on here, but it is going to be negative 32. Okay? So, now let's plot those points. Negative 3, 18 we can't graph, but negative 2, negative 8 we can. Then negative 1, negative 2. Oh, wait, hold on. I was way off. Sorry, kids. That goes there. That's not a point. Negative 1, negative 2. 0, 0 is still a point. 1, negative 2. 2, negative 8, and then we can't graph anything else, but we can connect our dots. okay? So we've got a parabola that looks like this now. So now we're going to come through and figure out all of these descriptions or these characteristics about this specific parabola. So first of all, we have our vertex, and our vertex is where the point turns around. Okay, so our vertex is right here. This time it is a maximum because it's the highest point on our graph. This time we're going to go on and, excuse me. We're going to go on and on forever in both directions downward, so we don't have a minimum, but we do have a maximum. Okay, so it's a maximum, and it is still the point 0, 0.
Once again, the weight room is closed after school today.
Oh, man.
And the weight
Don't
room
go to the weight room.
closed after school today. Just a reminder that the only students that should be staying after school are those who are staying after for sports or school supervised activities. If you're staying for sports or school supervised activities, you need to be with your coach or your staff sponsor by 2:30, so you should be there at this time. Students waiting for a ride, you need to wait in the student comments area. All other students, please make your way home.
Go home. Okay, anyway. The axis of symmetry, so if we were to fold this parabola in half, would still be exactly where it was last time. So this is still a vertical line. Vertical lines have an equation x equals, and we're crossing our x-axis here at 0, so that's the axis of symmetry. The domain, again, is all real numbers because there's never a point if we were riding this roller coaster that we would fall off the roller coaster. The range this time, okay, if you notice, we're kind of in the opposite kind of situation that we had the last time. And the last time that we had it was that y had to be greater than or equal to 0. But this time you notice that all of the graph is happening when y is less than or equal to 0. So it doesn't matter what the x values are. The y values are always going to be negative. And that's because the number out here is negative, by the way. For those of you that are kind of seeing some patterns, that's why. Okay? So that's nice. Okay, let's look at something here where we've got, go back to y equals, and we've got x squared minus 9. Okay, so we go to our graph just to see, okay, what's this going to look like? Oh, okay, so you notice it kind of moved somewhere else. The vertex is no longer at 0, 0. We've moved it. So we go to our table, and I'm going to start at negative 4, 7. And then we've got negative 3, 0. Negative 2, negative 5. Negative 1, negative 8. 0, negative 9. 1, negative 8. Positive 2 now. Positive 2, negative 5. Positive 3, 0. And then we could put the 4, 7 on here if we wanted to. Okay? And so now we're going to graph this parabola. So negative 4, 7. Negative 3, 0. Negative 2, negative 5. Negative 1, negative 8. 0, negative 9. And hey, if you notice here, these points just reflect on the other side. Or if you don't see that yet, you can still plot all the points. Oops, that goes up there. No, that goes there. Just kidding. And then we do our best to connect the dots. It's not going to be perfect, but we do try our best here. Okay, so there's that. Okay. So this opens up. I know I didn't ask that on the last one. I'm not sure why, but it opens up. This time we have another minimum. It is down here, okay? And that point now is 0, negative 9. That's the coordinate point of your minimum, all right? The axis of symmetry just goes through here, okay? And it's still x equals 0. We will eventually move it, don't worry, but it's still x equals 0. The domain, again, is all real numbers. And hey, guess what? For parabolas, it's probably almost always, I don't want to say the word always, but almost always all real numbers. And the range, okay, we have to talk about when things start happening. Things start happening anywhere above this point up there. So we have to be bigger than or equal to, and the y value right there is negative 9. Okay, so the We've got to be bigger than or equal to negative 9. Not too shabby, as long as you know how to use a graphing calculator. If you're having issues with the graphing calculator and you don't know how to graph it or where the X button is, talk to me and we can figure that out. Okay? So now let's talk about a few more characteristics about specifically this parabola here. Okay, so if we go to the next page, it says, does the graph cross the y-axis? How many times and where? Okay, so here's your y-axis. It does cross the y-axis. It crosses once at the point 0, negative 9. So yes, it crosses how many times? Once at the point 0, negative 9. Okay? And these are called y-intercepts. You know this. This was the b value when you were graphing lines. Okay, so we still have y-intercepts. They're just parabolas now. Okay? So now let's look here. Does the graph cross the x-axis? And it does. It crosses the x-axis here and here. That's the point negative 3 and positive 3. So where it says, does the graph cross the x-axis? Yes, it does. How many times? It crosses twice this time. And where? It crosses at negative 3, 0 and positive 3, 0. Okay? And these are the x-intercepts. Okay? So those are just two more characteristics about parabolas that we're going to be talking about. These are very, very important, especially in Chapter 9. Chapter 9 is going to talk heavily about some x-intercepts. Okay? So let's do a few more examples here. So this is more commonly kind of what you're going to see. This is a parabola in standard form, a quadratic in standard form, excuse me. And so we're going to go to our y equals, and we're going to plug in this entire thing. So 2x squared plus 8x minus 1. And then we're going to go to our table, and we're going to start filling in at, looks like negative 5, 9 is the best place to start. And then negative 4, negative 1. And then negative 3, negative 7. Negative 2, negative 9. Negative 1, negative 7. 0, negative 1. 1, positive 9. And then we could fill in the 2 here at 2, 23. But I'm not sure that it would matter so much, okay? All right, let's graph our parabola. So we've got negative 5, positive 9, negative 4, negative 1, negative 3, negative 7, negative 2, negative 9, negative 1, negative 7, 0, negative 1, 1, positive 9, and then we can't graph the other one. Okay, so we've got a pretty long parabola here in terms of what we can see. Okay, so there we go. Now let's talk about all the things about this parabola. So, first of all, our vertex is now a minimum because there's a lowest point. Okay, it's down here. And that coordinate point is negative 2, negative 9. So you can either look on your graph for that minimum, or you can look at the table here, okay, because you turn around at that point too. So you can also talk about that as well, okay? And so now we've got an axis of symmetry, and we're passing through right there. Okay, so this is a new axis of symmetry, but it's still a vertical line, so it's x equals, okay? And this axis of symmetry here is at x equals, and the point we cross the x-axis is at negative 2, okay? The domain, again, is all real numbers. The range has to be bigger than or equal to this y value here, which is negative 9. Okay? And if you notice, that's kind of paired with your vertex. So that should work for you, okay? The y-intercept is where we cross the y-axis, and that's at the point 0, -1. And then I've asked you for the x-intercepts. And now this is difficult because it's crossing at a decimal. It's not crossing right where we think it is. So we actually have to use the graphing calculator for this. So if we go to y equals, okay, it's going to graph this, all right? And actually what we're going to do is we're going to use this button up here, this trace button, okay? If you hit second trace, and you have we've used intersect a lot, okay? We're going to talk about how to use the minimum and maximum a little bit later, but we've got this minimum and maximum here. And then, but if you notice, there's this other option of 0, okay? X-intercepts are also called zeros, and so if we click that, okay, we can actually have our calculator find where this parabola crosses the x-axis, okay? And so it's asking for a left bound. And so we're going to come over here to this 0 first. We're going to have to do this twice, but we're going to come and find this one first. So we come over, the left bound is if we were riding this roller coaster before we went into the tunnel or before we went underground, where would we go? And so you just need to be before you cross the axis right there and click enter. And then it asks you another question. It asks you right bound. And so you need to cross the x-axis, go underneath the ground this time, click enter. And then it asks you that dumb question of, do you want me to guess? And I'm like, yes, please. And then it gives you the point, 4.12. And remember, this is just 0. This is like -1 with 12 zeros in front of it. So that's just -4. Okay, so the x-intercept here is -4.1, 0. Okay, so that takes care of this one. And if you notice on your graph, that looks about right. Okay. And then we're going to do the same thing again for the next one. So we're going to hit second trace. We're going to go down to intersect. Okay, so you click intersect. And oh, no, sorry, not intersect. Second trace is 0. My apologies. 0. This time, the left bound is going to be before we cross. So it's before we go out. And then the right bound is just on the other side. Basically, left bound is what happens first. Right bound is what happens next. Okay? Click enter, and then click enter again. And this time, this 0 is the point 0.12, 0. So those are both of your x-intercepts, okay? Beautiful things. Okay, so there are 2 left, all right? I want you guys to complete these as your homework, okay? So I'm going to be checking all of this next class to make sure that you've done all 4 pages of this, but I want you to do number 5 and this should be 6. I don't know why it says 7. Number 5 and number 6 on the back, I want you to have completed, come and ready to go. See if you can do them by yourself, and then we will check our answers as a class. Okay? Good luck.